Hello, please let me introduce ST Microelectronics solution for 100 watt auxiliary power supply for industrial applications with very wide input range up to 1000 volt. There are several markets and applications that are using high voltages for its operation, like industrial drives, high power online UPS, and also, for example, solar inverters. All of these are going above standard wall socket 230 volts AC input voltage range, and also that implies a specific need for an auxiliary power supply. Auxiliary power supply is a small but a critical block in the mentioned applications. In general, purpose of the auxiliary power supply is to provide a power for main electronics. It means, for example, 10 to 12 volts for power switches and gate drivers and 5 or 3.3 volts for a microcontroller. The auxiliary power supply is usually connected on different positions and voltage buses depending on an application. When we take previously mentioned application, solar inverter, the auxiliary power supply can be connected in front of the main converters directly after the photovoltaic panel to allow zero consumption during the night and safety at the same moment to make electronics alive when the grid fails for safe disconnection. Similarly, on big online UPS, the auxiliary power supply is also needed to work when grid falls and is connected to middle DC link. Both of these examples need to have the auxiliary power supply connected to very high voltages. To cover these application needs, ST has developed a reference design ST-Eval ISA 211V1. This 100 watt auxiliary power supply is an isolated flyback converter able to work from AC line 230 volt up to 690 volt or from DC line 150 up to 1000 volt. The output voltage is 24 volts, what allows usage of a standard downstream converter to any desired voltage needed in the application. The board has an extended flexibility and designer can select either quasi-resonant or fixed frequency operation and also is able to enable or disable brownout protection. This board is currently in manufacturing and there will be a stock of them within October 2020. This reference design is completely built on ST products starting from 1700 volt super junction MOSFET from our K5 family, STW12 and 170K5, flyback controller L6566BH, output Schottky diode STPS 20 LCD 200C, 600 volt MOSFET STN1 HNK60 used in a high voltage startup circuitry, TL431 voltage reference, and STTH 112 plus 1.5 KE 350A rectifiers that are working as a peak clamp. A key factor of this solution is the voltage rating. Here I would like to explain why the 1700 volt switch is needed. The breakdown voltage rating of the main MOSFET is defined by a maximum voltage appearing between MOSFET's drain and source. Due to flyback operation, it consists of several contributors. First, it is the maximum input voltage, 1000 volt in our case, plus the reflected voltage defined by transformer strength ratio being from 50 to 200 volts typically, plus voltage spike caused by the leakage inductance, also typically between 50 and 200 volt, plus finally some safety margin being recommended between 10 to 30%. All the sum leads us to 1700 volt for safe and reliable operation in a harsh industrial environment. Other highlight of this reference design is a solution for a high voltage startup unit. Despite the controller L6566BH has an embedded startup of 840 volt, it is still not sufficient. This is why we have used a special circuitry. Here there is implemented MOSFET Q1, what is the 600 volt MOSFET STN1 HNK60, which is used together with a small Zener diode to extend the startup voltage even up to 1200 volt. Then each of the main capacitors C1, 2 and 3 with its related balancing resistors are then holding 1/3 of a total input voltage. We have made an extensive testing on this reference design to demonstrate all the corner conditions and behavior. The most representative is an efficiency graph based on a different input voltages from 230 volt AC, what is the blue line, 400 volt AC, green line, 600 volt AC, purple line, and finally the highest voltage 1000 volt DC, yellow line. It can be seen that full power efficiency, it means and the load is 100 watt, is above 86% at all the conditions. What is worth also to mention is the peak efficiency for a most common voltage 400 volt AC, and it was reached 88%. ST Microelectronics is offering several technologies for high voltage MOSFETs. This reference design is an ideal test vehicle to see the comparison between the switches, considering all being 1700 volt maximum breakdown voltage. We have tested the mature planar technology represented by STW3N170. Then we have used the superjunction MOSFET STW12N170K5, what shows us gain of 4% efficiency over the planar technology. And on top, there is also the most advanced technology of today, silicon carbide MOSFET, SCT1000N170, what is giving us even another percent of the efficiency over the superjunction device. In the remaining time, I would like to share a summary on a key power product families from ST Microelectronics, what can help engineers and designers to build a robust and efficient switch mode power supplies. L6566BH is a multi-mode flyback controller with a selectable operation. It can work either as a fixed frequency or quasi-resonant controller. It has an integrated high voltage startup of 840 volts. It has an advanced light load management for an effective standby operation and several protections like an adaptive undervoltage lockout, line feed forward for a constant power capability versus mains voltage change, pulse by pulse overcurrent, overvoltage and overload protection, brownout and transformer saturation protection. On top, there is also a programmable frequency modulation to help with a reduction of EMI. L6566BH is coming in a 16-pin narrow package SO16N. Superjunction MD-Mesh K5 MOSFET series is a one-stop shop family for very high voltage MOSFETs. It offers the most complete portfolio from 800 volt up to 1700 volt breakdown voltage, targeting mainly flyback topologies. Higher breakdown voltage allows a higher design flexibility and margin, together with industrial lowest RDS(on) for above 1000 volt switches, to have higher power and greater efficiency. Lowest total gate charge (QG) gives faster and more efficient switching. Last but not least, low input and output capacitances (CISS and COSS) lower significantly the switching energy losses. ST also offers a broad portfolio of rectifiers. Low voltage diodes below 200 volts with FAIRT and STPS series are having avalanche capability defined, higher temperature rating of 175 degrees Celsius, and low forward voltage drop. High voltage silicon diodes are covering voltages from 200 volt up to 1200 volt range, with a platinum doping for low leakage and higher reliability, again with 175 degrees Celsius rating. ST is already 10 years in production with silicon carbide devices ranging from 650 volt to 1200 volt devices with high robustness and low forward drop devices. Here, I would like to thank you for listening this presentation of ST Microelectronics.